Hey, what is good, you guys? Welcome back to the channel. And in day two of Observability 0 to Hero, we are going to look at metrics, logs, and traces. So yesterday we saw an example, right? So in the example, what we saw here is here. Yeah. So you have a load balancer here. Okay. So this scenario, load balancer. Behind the load balancer, there are three servers: 1, 2, and 3. Okay. And in these servers, there's a service running. So say the server runs an app. Let me draw it somewhere here. Okay, a cleaner version. So you have a load balancer, and let me draw only two servers. Okay, so here server 1 and here server 2. In both the servers, what we have is so on these servers, server 1 and server 2, we have the application running. Okay, so the server 1 triggers an alert, like same as yesterday here, that here we get an alert that CPU is greater than 95%. This CPU greater than 95% is a metric, okay, which is generated by the server. Similarly, we could have other metrics such as error rate, we could have memory, we have disk space. Okay, so the metric could be anything. Similarly, from the application, we could have custom metrics. So if the application, let me do one thing. So custom metrics such as maybe JVM or maybe HTTP status code. These are just examples, but what I need to understand, I need you to understand is custom metrics as well as metrics which are uh, emitted by the servers or any hardware or any infrastructure which we are running. So there are a variety of metrics, but essentially a metric is something which is measurable. So let me write down a definition. Metric is equal to measurable number. Okay, could be number, could be anything. Let's assume metric is a measurable number. Measurable number. Okay. Then what are logs? Okay, so we've covered metric. Now let us understand logs. Okay, logs. Logs is equal to uh, so here say in the same example. Okay, so request comes from load balancer. Here it goes to service. So load balancer sends it to server 1, that is the application 1, and from application 1 the request comes here and hits the cache. The cache is a miss. So what it does is it goes to the DB database. Okay, so your request flow is load balancer. So this is 1, server, this is 2, cache 3, and database 4. Database 4. So what would our logs look like? Let me go here. So logs are essentially what is happening in the application right now. So request received at LB. These are just examples. Okay, request. These logs would be logged at different places, but these are just examples. Then application processing request. Okay. Then cache miss, and then the last EB hit. Okay, so this log is printed at say 7:00 p.m. Okay, so then this is at 7:01 p.m. Cache miss is also at 7:01 p.m. And then let's say instead of DB hit, we get a DB await. Okay, this is at 7:01 p.m. and say also at, say we get another DB hit, DB await at 7:01, then another db timeout at 702. So these essentially logs of lines which are printed about what the application is doing at that point in time. These are called logs. So metrics is a measurable number. Logs are, say, indicate application workflow. Logs indicate the application workflow. That is what is happening in the application. Okay. Now then, what are traces? Okay. So we have covered metrics. We have covered logs. Let us now understand traces. Okay. So here we saw that the request went from the load balancer to the server 1. From there it went to a cache and it went to a DB. So the request flow path is 4. Okay, there are 4 flows in that entire request. LB to server, say, and let me add another one. Okay, from the server, within that server it went to the app. From app it went to the cache, and from the cache it went to the DB database. Okay, so this is your entire flow. So the request could go wrong at any point. We have assumed here in this log that we are getting a DB timeout. So the request is problematic here. Problem. Let me highlight it in here. It is here. It is problematic. So what the trace would tell you, how a request flows, or the end-to-end journey of a request is what trace would tell you. So the request first arrived at the LB here 1. It went to the server 2. It went to the application 3. It went to the cache 4, and then it terminated at 5. So this entire flow, to link this entire flow, we need something. Okay, and that is what a trace is. So a trace links an entire journey of a request through your entire services. In the olden days, the request would be simple, that we have one server, the application is running there, that database is again running on a different server. So you have two, the request is basically from the user to server to database. That's it. But with the distributed architecture, we have stuff like API gateway, API gateway. API gateway would forward it to, say, a server, or multiple servers. There would be hundreds of servers, depending on the size of your application. Consider a Netflix level application here. So then this server sends it to maybe a third party. Okay, so there is a third party. Okay, then third party again does its own operation. Similarly, you could have here a database, you could have cache. Okay, so as the number of components increase, the request flow increases. Okay, the complexity of the flow increases. So if you want to pinpoint where things went wrong, you need to know how the request has flown through your system. You need to have a clear indication, and that is what a trace does. The trace, or a trace, gives you a clear end-to-end flow. Now traces are not magically generated. You need to specially generate them. Okay, so metrics are something, again, as metrics for CPU and all, they're generated by the operating system. If you have custom metrics, then again you need libraries for that, depending on whether you are using Python, whether the application is Python, whether your application is Java, Golang. You need to instrument those custom metrics. Logs, they're written in the code itself. Okay, so the logs are written in the code itself. The traces again are specialized, and they need to be generated and cascaded across the request. So the trace ID, for example, in our case, it would say originate at the load balancer. Then it has to be propagated from the server to the app, not the server, but say from load balance. Let's take this example. Okay, this is a good example actually. The request has to originate, or the trace has to originate here. Okay, it has to be propagated to the server, that is the application. From application to the third party. Let me draw it better. Okay, so one box here, one box here, one box here. This is a third party. The third party does its own processing, and database here. Okay, so app then db or say cache, cache, then db third party, and this is another say uh, app 2. Okay, so the request comes in here, then goes here, then goes here. From the db it does some processing, it returns back to the app. From the app, then another flow goes to this app 2, and from here it comes to third party, and third party the request goes back to this app, and from here it comes back here. Okay, so this is a complicated flow. So it starts here, 1 2 3. From here the request came back, right? So here this one, this is 4. From here it went back to 5. From here it came back to 6, 7, and from 7 it has 8. So there are 8 flows, and this is like a simple architecture. Nowadays architectures are more complex than this. So this is a simple architecture. So to trace all this, all these systems have to propagate that trace throughout the request, so that when the request times out or anything happens at any point in this 8 flows, you could see it in a single view, and you could confidently tell that the request broke at the cache or a db or a third party or app 2. The responsibility is that these traces have to be reliably propagated. There are libraries available for that as well, but traces have to be generated and propagated from one system to another. So that is about traces. So where did we do this? Here, traces. So traces is equal to system flow. Okay, traces can be system flow. So logs indicate application workflow, or what is happening in the application. Traces indicate system flow. So that is the clearest and the most simple explanation I could think of for metrics, logs, and traces. And all three are very key to observability. And in fact, they are called as three. Oh, a bad way to write three pillars of observability. Observability. Okay. Logs, traces, and metrics. Logs, traces, and metrics. Metrics. This is why these concepts are so important, and they're called three fundamental pillars of observability. I hope this is clear. If you have any doubts, leave them in the comment section, or if you are watching this on Twitter, leave a comment on the post, and I will try to respond back. If I've missed something or I've mis-explained anything, do point out that as well. Thank you for watching.